Hello, I'm Chris Athanas. I'm a KMP developer, and we're doing a course. Talking you through a course here on how to program from the ground up. And I heard from tech support. They're coming out Tuesday, so that's when they said they're coming out. So we'll hopefully have that portal closed, and we'll get that cleared up soon enough. So we're going into the procedural. We just talked about basic, the introduction to basic. Now I just want. It's like people ask, well, where did basic come from? It was just written in assembly language. Somebody was just like, okay, we got to write something a little easier for this. So they started some techniques and doing it with COBOL. Right here, COBOL and Fortran. So with COBOL and Fortran, they already had a bunch of techniques for like converting text, manipulating text, like parsing text into tokens, like little things they could then manipulate and then do their own little microcode, basically program inside of software and assembly. They just wrote it in assembly. And so they had all these techniques that were being collected. And then with basic, they're like, hey, we can do the timeshare thing and this high level stuff, but even make it even simpler so like anyone could use. So that was the big idea. There. And if you want to, okay, so we got it up. So they let everybody got into it. So there wasn't much training. There wasn't much, like a couple days, a day and a half, a day maybe, until they told all kinds of people how to use BASIC, and all they heard was let, go to, print, and if. That's all. That's kind of where people's heads at. Now, they did mention there was go sub and return in there, but people were like, what? I don't even know what that is. I just need to get my assignment done. So the go-to thing became the thing to do. It was a main part of assembly language programming as well. Like, it was just part of how you did it. It was jumping around. Even though it had call and return, not a lot of people used it because it was not standard across each computer. I mean, nobody was really thinking about trying to do high level stuff. They just got their little thing they wanted to do and moved on. So a lot of programs are written like this, and you can take this program. I've actually created a little extra repo here. We can go in here, copy the program that we're about to go mess with, and you can go over here to this AppleSoft Basic at this thing here, and you can test that it works. You can here print hello world, the standard test. And then you can just paste the code in here and run it, and you'll see it runs, right? But look at this code, though. I mean, actually take a look at it. Okay, we assign a variable, which is actually a expression. Let's do that here. So this is an expression because it assigns a value. Expressions and statements are so different. They're so different. Okay, one doesn't return a value, and one does. Okay. Some languages, everything's an expression, like Kotlin. Kotlin always returns a value, even if the value is void or unit or none. The value is actually the none, the word that means nothing. It's so funny. But it does make sense if you go through their reasoning why you have to have these things this way. Anyway, but this is before they were still arguing. It's like, no, we can just do statements. We can just do expressions. No, they're very different. It's like, okay, whatever, man. Anyway, you can just do expressions. Everything's fine. So this is a statement. Go to 100. And all that it says here is, everything's got a line. Every line has a line number, right? And this means change the next execution to line 100. Okay, so it jumps down to here, just like in assembly. Oh, except instead of having an address here, you're typing a line number. Okay. Anyway, this blew people's minds. So they went crazy with this kind of stuff. So they said go to 150, down here to 150. This go-to stuff can get confusing. And then you can hit line 160 goes to 60. And if x equals 10, so I have to remember x equals 10. Okay, so x does it, so it goes to 190. And 190 is down here. How did I get here? End. All that jumping around stuff, it's called spaghetti code. And people made huge programs with this, just with this go-to stuff. So after a while, they said, okay, people that got into it were like, okay, there has to be a different way. So they added this thing called these reusable word, a keyword, language word, which is kind of just like a function that you could, this is basically the start of functions in languages, or at least high level languages, where you would go to a subroutine, like here's a subroutine right here, and this subroutine is, the rem means remarks and comment. It would just add two numbers and put the result z. So you let z equals x plus y, and this is the return. So wherever it came in from, like here, whereas you do the go sub here, it would just go in here and then we return right to this next line. And then they would execute this line, and then it would come down here and they would go sub to 100, do this thing, and come back to the next line. And notice the result is coming into this variable z. All variables in BASIC are global and mutable. Means that any line can change it and any line can assign it. So that wasn't causing problems at all. Oh, and you only got one letter. They let you do strings too. I won't get into that, but you can try to explore that if you want. But you had one letter. And people's minds were blown with this. They were like, what? I could do all kinds of stuff with this. So let's go do this. Let's go get this program. So go over here. Ding. Boom. Okay, so the output is 42 and 142. And that blew people's minds that they could go do this on the teletypes, and then at home, when people got used to it. So then people were like, well, how do I make it do one thing after another? Well, in the beginning, people just did these. They would do these kind of programs that they would call it unroll the loop, right? Instead of doing a looping around with a go-to, right? They would use this thing. They would use this structure, and they would, of course, do the exact same as the previous program that was here. Go over here. Okay, so we go over here, delete this one, paste it in, and here, play. Okay, so it's this. So this does a program that does this add thing. This is a big nonsense thing, but just shows you how procedural worked. An imperative. This is completely imperative. Like it's not even trying to do a loop here. It's like just doing the exact command. And this is actually a style that the compilers in assembly and higher level language will unroll. What's called unrolling the loop. Well, they have this. So the solution was to do this declarative. So this uses so people would roll their own loops, right? They would do their own loops thing, just like they did in assembly. So they would have this is before people started using the for loop. The clever ones was like, oh, I could just use a couple variables, right? And I could use a couple variables and do my own loops here. Let's go see what that's like. So it's easier to demonstrate this than to talk about it. So it's going here. So it's let's a equals 1, goes sub 100, does the calculation, returns, prints it, and then at a plus a equals 1. And if a is less than 10, it goes back to the top again and loop until the end. And this is, stop the program. So let's go ahead and play it. Let's see what happens here. Oop. All right, that's right. You can't copy these. That's right. Because I've had these little comments here. So you actually have to go in here. I made the mistake. Here we go. And there you go. And run. Okay. Same result. Okay. So this is a refactoring, right? So now I've not done the naive loop. I haven't done this naive like imperative looping thing. And now I've gotten clever. I can do this little if then else thing. If then, type of thing here. And then the people are like, oh, let's just put this high level declaration called a for loop, which is actually, let's just say loop here. Let's just say loop. Loop A equals 1 up to 1. But they used the for because it came from Fortran, and some people are already used to the Fortran. So this is like these languages kind of evolved from the previous one. Like they're spiraling forward. A little bit back, a little bit forward, a little bit back, a little bit forward, a little bit back. That's been the whole time. That's how they've done it. So using a for loop here, you say we're going to make this value A go from 1 to 10 each time it hits a next. It goes, it increments to 2, the 3, the 4, the 5, 6. And then steps 1 means, we don't go step 2. We don't go 1 to 3 to 5. We just go 1 to 2 to 3 to 5. So you can go step 1 or step -1 if you want to go backwards down. So let's look at that. Let's see what that looks like. I should go in here and play with these and see how hard it is to like change these programs, or try some of these samples here. He's got a whole bunch of samples, so you can see how it's all put together. Okay, so same result. It's just refactoring to using more condensed commands. And this isn't just for you, right? This is for someone else who looks at this program and goes, "Oh, we're doing a loop here." I don't have to look at this and go, "Why are we adding A plus B? Oh, okay. Oh, we're doing a loop. Oh, this is doing a loop here. Got it. Oh, okay. Now here, there's no question. It's like, yes, we are looping. This is the only thing this does. It declares the loop here, and gets the next. It loops it back here, and everything in here runs. That's the whole idea there. All right, so that's procedural, imperative, a little taste of declarative, a little history lesson on how Apple and Basic changed the world. Really, is what they did, because this opened people's eyes that didn't want to do assembly language. You can see why people don't want to do assembly language. You got to be really into it and really want it for a really good reason. But this, is more casual. You can get into it pretty easily. And especially when you start to do strings and you can play games and do all kinds of calculations with it. It has all kinds of, it inherited all that math calculation expression stuff from Fortran after they figured out how to do that in assembly. Yeah, so this is when things got exciting for sure. All right, so next up we're going to be talking about a little bit about software design.